All right, this is the really juicy part. So we are now going to sub-select a population from the big distribution. We're going to do that using a NumPy function, numpy.random.choice. And this is a function which says, okay, give me a size, 820,000, and I'm going to take 820,000 I'm going to select that, choose that out of the bigger population. But I'm going to do it in a way that is weighted. I'm going to favor some items over others. And you're going to pass in a list of weights, which I will use. Okay. And the way we come up with those weights, I'm going to penalize cheap things. I'm going to say that take the price and square it as a way to encourage it to pick expensive things. And I'm also going to penalize tools and home improvement, the whole category, and the category automotive. And I'm going to really penalize that category a lot. And I had to penalize that a lot because, unfortunately, also car parts are often the more expensive items. So this weighting tends to favor car parts even more. So I had to really ding it by multiplying by 0.05 to get a good distribution. So hopefully you get the idea. This is very iterative, very experimental. You take code like this, you shift around the weights, you keep playing until you end up with a distribution that you like. So let's see this distribution we're going to get right now. I'm running this. It's doing this selection from the bigger population. We now have ourselves 820,000 items, and let's have a look at how their price is distributed. This is the price of the items. And you first might look at that and say, okay, well, it's still very skewed. Well, it was always going to be pretty skewed because we didn't have that many expensive items in the first place. But actually, the skew is a lot less. I think the average price before was $59 or so, and now it's $140, a much more respectable average price, more aligned with the kinds of things that I want to test our model with later. And you can see that there is a fatter tail here. There are more items. You also might notice there are these spikes at various points. And these spikes are because it tends to be that products are often priced at like $399, $499. And you might wonder why don't I correct for that as well? Well, that's because that is a real feature of the data itself. It's true in the real world that products are likely to have prices like that. So in fact, we sort of want our model to know that and to be able to learn from that too. So it's good to have that in our data. So here we have it. It's still skewed, but not as skewed as badly. Definitely corrected. And this is the kind of distribution that I was looking for. Okay, and I'm just going to shuffle up the data one more time. I realized that we've already done that by selecting from it, but still, it's a good practice to do a random.shuffle on your data that mixes it up. And I'm doing this thing here, random.seed42. Setting a random seed is a way of fixing the random numbers so that they're the same every time that you run this, so that you and I end up with exactly the same data set. The reason that you pick 42, you'll see that it is customary to see people setting the random seed to 42, and there's really two reasons for that. The reason that you do it is so that it's clear that you're not cherry picking. 42 is a bit of the standard number people pick, and so by always doing 42, it shows that it's not like you're experimenting with many different numbers until you get a number that happens to give you good results. You're just going with the one that people pick, 42. That's one reason. The other reason, of course, is that it's paying homage to the Hitchhiker's Guide to the Galaxy, the answer 42 to the life, universe, and everything. It is like a nerdy joke, a nerdy little shout out to that. It's why everyone always fixes their seed at 42. And here we have it. We are now going to look at the prices one more time, and it is, of course, the same as before. Shuffling around didn't affect the prices. And we're also going to look at how how things are distributed into the different categories, which was the other thing we corrected for. And here we have our final categories, and it looks perfectly decent. Electronics in first place, tools and home improvement, and then automotive. Seems like a nice little distribution of different categories. Sure, appliances and musical instruments are right down there, but then there are way fewer of those items. It would be weird if they were all the same. So this seems like this is perfectly acceptable. Plenty of car products, but not so many that it's overwhelming our data. Okay, and now let's look at that in a pie chart, because some people love pie charts. Here it is. You can see, yep, clearly nothing is dominating. It's not like we have the automotive domination. It's a nice distribution of products. And as I say, if this feels like a bit of a dark art, that's okay. You should get a feel for it. You should experiment, curate a different data set. The key is what performs best when it gets to training. Okay, we're then going to do just a couple more looks into whether there are any characteristics of the data we should know about, and then that will be a wrap for today. Let's finish this off. An important thing to look at with your data is correlations. Is it clear that your data has some relationship with there's a relationship, say, between price and something like how many characters are in the description? Maybe it's the case that longer text tended to be associated with with more expensive items. And so we can do that by plotting a chart to try and see whether that is the case or not. So here I'm looking at this very noisy chart here, which is showing for a particular number of characters in the description, how much did it cost? And yeah, it doesn't appear that there's much going on there. I'm not seeing much correlation there. Nothing that I can tell. And how about with the weight? Is it the case that heavier things tend to cost more? It might be, and well, it does appear there's something happening here, right? There's a lot of noise because there are things that don't weigh anything, and or at least not that in the Amazon description, and yet they have a high price. But there does seem to be something going on here. So we might have some inkling that weight is something that can be part of a prediction of how much something costs. All right, that's the end of looking at a couple of correlations. You should look at more. You can think of different ways you could dig into this data, think of different ways to analyze it. Use these visualizations. Of course, I'm using matplotlib, and this is just a cookie cutter stuff that you can copy and paste and change the dimensions, make new histograms, make new bar charts, take a look at the data. You need to have a really good feel for this data because we're going to be doing some serious data science with the data, and it's great to know about it first. Okay. And with that, the final step is to now upload this curated data to the hub so that the people that don't want to go through all of this, like maybe you, can then just download it from the hub, and it's already being curated and it's a great data set. So we'll do that now. So it's super easy to push stuff to the Hugging Face hub. You need to have your username, and I suggest if you want to just use my data, then just keep my username in here. These datasets will be public. You can choose for your datasets that you make to be private or public. They're private by default. When you make it public, it means anyone can just download your data. I'm going to make 2 different datasets, and throughout the next week, and throughout a couple of weeks, we're going to be having these 2 different parallel datasets. One is going to be called full, and one is going to be called light. And full is the big, heavyweight, all 820,000 items for people that want to really go for it. And light is a more civilized 20,000 to 22,000 data points for people that want to do some training, but don't necessarily want to spend several days doing it, if you're not as much as a big old nerd as I am. So full and light are going to be these 2 different data sets, my name, and then items raw full and items raw light. I'm going to divide into training, validation, and test data. Remember those 3 pools of data. For the big one, the training data will be 800,000 items, 10,000 of validation, 10,000 of test. And I'm going to push that to the hub. The other one is going to be rather smaller. It's going to be 20,000, 1,000, 1,000. Push that to the hub. So I'm not going to run this right now because I already ran it. I've already uploaded it to the hub. You'll see it in there with these names. They are public. And tomorrow we're going to download them and make use of them. And that is our data set curated. And I put a fun little side note down here that I love making these different visualizations. And there's a whole set of different colors that you can use to have different types of chart. And there is a rather useful web page where it will show you the different colors that you can use here for your different charts. I hope you'll explore this. I hope you're going there now and making tons of visualizations so that you've really got to grips with this data and you know it back to front. And with that, we will go back to wrap up this day and congratulate ourselves on curating an excellent data set. And so congratulations, you have either created your own training, validation, and test data set, or you've watched me do it, you've understood enough, you're fine with it, you're happy that I've done it, and you're ready to download it from the Hugging Face Hub. As I say, it's not super critical that you do this curation. It's more important that you get the general idea, you get the gist of what it's about, you understand that we've curated this data set, we've got rid of anomalies, we've got rid of things we don't care about, like items without a price, and we've taken a sample of the distribution, which seems to have a good representative population of the kinds of atoms that we care about, and with the kinds of descriptions that we care about too. That's what it's all about. Okay. Congratulations. In addition to everything that you've been doing with open and closed source models, in addition to RAG with LangChain, you can now select, investigate, curate your very own data set based on data that you've pulled from Hugging Face or from anywhere else like Kaggle. Okay, next time, lots of stuff. Tomorrow, we're gonna go through a 5-step strategy for selecting, training, and applying LLMs. We're then going to do something really interesting, which is pre-processing data sets. And this is a hot idea from the last 6 months or so of people using LLMs as ways to improve the quality of their data. And of course, there's also like an advanced RAG technique to pre-process your data. So we'll be doing that. It's also going to be an opportunity for me to show you about a different way to make API calls to LLMs known as batch mode, which is when you don't call in a kind of synchronous request response kind of way, but instead you submit a batch of requests and later you come back and collect a batch of results. And this is like a pro technique. This is like an advanced LLM engineering technique. And so I'm really happy to be able to show it to you. Okay, tons to do. It's just a bit more data stuff before we get to training, but it's worth it. It's going to be great. I'll see you tomorrow.